Nothing says America quite like baseball.
Baseball is one of the great common denominators of American life. When game time rolls round, there are no social barriers.
Hot dogs and home runs, base sliding, and big hits. For decades, it's been the country's national pastime. And so you guys figured it'd be the perfect arena for the Mythbusters to take a swing and a myth.
You guys like baseball?
Are you kidding? I love going to the ball game.
Well, so do our fans, and they have inundated us with baseball myths to bust.
So what have we got?
Can a cork bat hit a ball further?
And what about whether sliding into base is quicker than running?
How about the one, does a dry ball go farther than a humid ball?
Exactly. And can you hit a baseball so hard, you knock the hide right off?
Sweet.
And we have got a real baseball legend to help us out.
Who?
None other than the Roger Clemens.
Roger Clemens? How did we get him?
Turns out the Rockets fan of the show.
Let's play ball.
That's right, it's the Mythbusters and the Mythbuster. He's one of the all-time baseball greats, pitcher Roger Clemens. In a career spanning more than 20 years, the man they call the Rocket has won a World Series and taken out the prestigious Cy Young Award an amazing 7 times. He also happens to be a big fan of Mythbusters. And Jamie's stammering with excitement.
I'm speechless to have the Roger Clemens here helping us deal with these baseball issues.
Later in the show, we'll study the mojo of the throw and answer once and for all the age-old question. Can a baseball really slide and curve? Or is it just an optical illusion?
I'm going to try and give it my best out here so you can tell what this baseball actually does with these high-speed cameras.
On this Mythbusters baseball special, it's time for our Rocket Roger Clemens to step up to the plate.
I might reach 90 miles an hour today for y'all.
Roger's agreed to throw his whole taxonomy of pitches for us while we shoot it with the high-speed camera from several angles, and that really ought to allow us to break down what's going on from a physics perspective with each of these pitches.
The team is hoping to use the high-speed camera to unravel the mojo of the throw. But to warm up that famous arm, the Rocket first puts some pitches in front of Adam and Jamie.
Room service is right there. It's like
Okay.
somebody bringing you breakfast in the morning. I'm going to put it right there. You can't miss it. You can close your eyes and hit it. That is a bat. That's not a broomstick. Now swing like you're off. Hey, all right.
The Mythbusters may be struck out, but with the Rocket firing on all cylinders, it's time to unravel the parameters of the pitch. First up, a basic 4-seam fastball.
We hold the fastball in this manner, and from my understanding, this ball rotates when I let it go in this manner. With 4 seams, these seams will catch that wind. That ball will track.
Fastball is like watching a dart go, man. It's beautiful.
Looking at the high speed, the fastball pitch does exactly what Roger said it'd do. Backspin keeps the ball on the straight and narrow as it rifles over the plate at more than 80 miles an hour. But what happens when Roger changes his grip?
Basically, if you're a fastball here, you're in this area for the slider, and you're offset, and you're basically cutting the side of the ball. It should go maybe down 4 inches and away from a right-handed hitter 4 inches. That's a true slider. There we go. You know it's good when the catcher doesn't catch it.
Rogers found perfect pitch again. The slider veers away to the right of the plate,
Curveball.
while a classic curveball suddenly dips in midair.
The curveball, again, you're using a seam, and it's basically your middle finger. You're grabbing a seam and locking down with pretty firm pressure on this finger here. This one just guides it.
Okay.
And it is a motion where you're throwing it like a fastball, but as you get to the release point, you turn your wrist.
Coming out of Rogers' right paw, it's almost as if the ball has a life of its own.
I can see that curving.
Yeah, this speed, you'll definitely see it curving.
But while the high-speed shots show us the ball swerving and dipping, they can't tell us much about how it happens. And that's why Carrie, Tori, and Grant are at NASA's Ames Research Center in San Francisco. Luckily for us, scientist Rabindra Mehta is a big baseball fan.
The beauty of our lab is that we study aerodynamics, fluid mechanics as applied to airplanes or space shuttles, but it's the same fluid mechanics, aerodynamics that's applied to baseballs or soccer balls or what have you.
So basically, you have married your two passions for
Exactly.
science and sports.
Isn't that wonderful?
Okay, so we heard that you actually have a tank where you can show us all of these things visually.
Yes, absolutely. What we'll do now is go over to this water channel where we have a baseball. As you see, it's mounted on a motor, so we're able to rotate it to show you the effects of rotation. But when you see what's going on here, I think it's going to be really cool.
To simulate airflow around a baseball, they introduce streams of fluorescent dye.
Sweet!
While it's still, the dye flows in a symmetrical pattern around the ball. Now imagine that ball has just been fired from Roger Clemens' fist.
Oh, wow. Look how the aerodynamics change.
As it spins, the airflow is disrupted. The air pressure on the ball's underside suddenly drops.
And this ball now will have a force downwards as it's flying through the air. So this would be your classic curve ball.
Lower air pressure on the bottom of the ball makes it dip during flight. And the principle's exactly the same for each different pitch.
It is the axis of spin that determines what type of pitch it is. With a standard fastball, which is released with backspin, you get an upward lift force. With a slider, the axis of spin would be more or less vertical, and in which case the ball would tend to go towards the left because of that. Then the curveball, tumbling. Spinning about the horizontal axis makes it go down.
So our high-speed shots and NASA show that bendy baseball behavior is no myth. So what about the infamous rising fastball? Many hitters swear that some fastballs suddenly lift in midair as they hurtle towards the plate. Is that a myth?
Now, for it to rise, the lift force due to the spin would have to exceed the weight of the ball, right? That's pretty simple.
Sure.
Now, it turns out that for the type of conditions which we find in baseball, the maximum lift force is only equivalent to about half the weight of the ball.
Not even a pitcher as prodigious as Roger Clemens can make a baseball fly in the face of physics. Throwing a fastball that rises is about as likely as Adam and Jamie hitting home runs in the World Series.
You know, hanging out with Roger Clemens, it becomes really clear that pitching is just as much of an art as it is a science.
Totally agree. And while we were there, we had the added bonus of another myth busted.
Yep, the myth of the rising fastball. And it turns out that for the backspin to exert enough force to lift the ball, it'd have to exert more force than the weight of the ball.
Which it can't.
Which it can't.
Yeah, it might be possible with a beach ball, but not a baseball.
Busted.
Totally busted.